Yeah, for question 10, we have a curve is described by the equation. We have the equation s cubed minus 12x plus 3. Find the tuning points. B, identify the nature of the tuning points. And then C, find the coordinates where the curve intersect the what? The y axis. Intersect the y-axis. Okay, for the tuning point, to get the tuning point, it's very simple. What we need to do is that we need to find the derivative. The y, the first step is to get the derivative. Okay, and the derivative of this one, y equal to s cubed minus 12x plus 3. The derivative will be equal to what? 3s squared. Derivative of this one, 3 will go to the front, and then this power minus 1. Derivative of 12x is 12. Derivative of a constant, 0. Then at the tuning points, the derivative, the y dx will be what? Be 0 at that turning point. Y dx will be 0. So then we now have 3x squared minus 12 equal to 0. Okay? Then, and that will be equal to, we can do something here. Here, what is common? 3 is common. That will be s squared minus what? Minus 4 equal to 0. Okay, so divide both sides by 3, and you have what? X minus 2, the bracket what? X plus 2 equal to 0, because this expression is a difference of 2 squared. And that implies that this is equal to 0, this is also equal to 0. So s is equal to 2 or minus 2. So these are the tuning points. Okay, and if we have the time, we can get the corresponding y value. Let's do that. When s is 2, let's get y. This will be 2, this will be what? 2 to power, this will be 8. Okay, then minus 2 times 12, that's 24, and plus 3. Okay, so, and that will be equal to 24 minus 11. So that will be equal to minus 24 plus 11. Okay, so that will be what? That will be minus 13. Okay, out of when x is minus 2, let's get the coordinates for that one. When x is minus 2, so that will give us what? Here, minus 8, minus 2 here, that's plus 24. That would be what? 24 plus 3, that's 27. 27 minus 8, that's 19. So that's finished that one. Then the next one is identify the nature of the tuning points. If you want to do that, you need to get the second derivative. Get the second derivative. Get the second derivative, and that will be d square y dx square, and that will give us what? That will give us 6 what? 6x. Just differentiate this one again. Okay, that will be 6x. Okay, then put your this one at the x value. At x equal to 2, let's check that. That's what? That's 12. So that's equal to 12. And when your second differential is greater than 0, that will be what? That point is what? Is minimum. That's minimum points. That's minimum. Then the second one, the square y, the s square, at s equal to minus 2, that will be what? 2 times minus 2, that's minus 12. This is less 0. So that point is what? It's maximum. Okay? S equal to 2 is what? Is a maximum point. It's a maximum point. Okay? Part. Find the coordinates where the curve intersects the x-axis. When the curve intersect the y-axis, when the curve intersect the y-axis, let me touch this y-axis. Okay, it implies that x is what? X is 0. Okay, so let's substitute that into the given equation. So y equals to what? X 0 cubed minus 12 times 0 plus what? Plus 3. So the coordinate is what? The coordinate is 0, 3. That finished that question. Yeah, question 13. Find the area enclosed by this equation. s squared minus 9x plus 20, and the x axis, Okay, so that's the solution to that. What this means is this: if this curve is enclosed by this equation and the x-axis, it implies that y is equal to 0. That is step 1. Then equate that y equal to 0 into this expression. That will be equal to 0 equal to what? S squared minus 9x plus 20. Okay? So, and that will be equal to 0 equal to what? You compare these s squared. 1 here, 1 here. The factors of 20, I can give you minus 9. That will be minus 5 and minus 4. And if you multiply minus 5 times minus 4, you get your plus 20. So this equation now implies x minus 5 is equal to 0, or x minus 4 is equal to 0. So we now have s is equal to what? S is equal to 5 or 4. So therefore, the area enclosed by that curve will now be integral from 4 to 5 of the given expression, s squared minus 9x plus what? Plus 20 dx. That's the area using integration. Then this will now become, the area will become integral of this of s squared is 2 plus 1, that's 3 over 3, minus integral of 9x, that will be minus 9x squared over 2, and then plus what? 20x. Then put the upper boundary and the lower boundary. Okay, so for the how to integrate, I'll put a link in the description for more elaborate illustration on how to integrate. So this will be equal to 5 to power 3, do the upper one first, over 3 minus 9 over 2, 5 square plus 20 times 5. So I'm done with the upper boundary. Then for the lower boundary, that will be equal to what? Anyway, you see x, you put the 4 there for the lower boundary. That will be 4 to power 3 over 3 minus 9 over 2, 4 square. Okay, then plus 20 times 4. Okay, so that finished that. So if you punch your calculator, that will give you minus 1 over 6 for the area. And the area must be positive. So you take the absolute value of that, so that will be equal to what? Minus 1 over 6. Take the absolute value of that value, and that will be equal to what? 1 over 6. Unit what? Unit squared. Okay, so that's the area.